All right, here's another little problem involving, let's say, a tetherball that's suspended by a cord like this, and let's say the length of that cord is L, and the tetherball has a mass of M, and it's spinning around this pole at a rate of, let's say, I don't know, let's see, 30 RPM, for example. What we want to know is, what is this angle theta right here that the rope makes with the pole? Okay, so here's how you go about this. First of all, let's look at the forces acting on the mass M. This is the force due to gravity, which is just mg, and there's the force due to the tension in the cable, which looks like this. There's a tension in the cable acting in that direction. This is angle theta also, so it is this vertical component of the tension here, this, that offsets the weight. In other words, T times cosine theta is equal to mg, and it is the component of the tension pointed inward, this component right here, T sine theta, that's equal to, or rather produces the centripetal force, is the centripetal force, and that's equal to mb squared over r, or that's also equal to mr omega squared, where r is this distance right here. R is equal to L times sine theta, L sine theta. So the way to solve this equation, or one way that's fairly quick to get rid of t, would be to divide this equation by that equation. And if I do that, I have t sine theta over t cosine theta, so that's just tangent theta is just equal to m r omega squared divided by mg, and the masses cancel out. Turns out I don't even need to know what the masses are, so that tangent theta, in fact I'm going to write it again as just sine theta over cosine theta like this, is equal to omega squared over g times r, but r is equal to L sine theta. That's why I wrote it this way, in anticipation of being able to divide both sides by sine theta. So that tells me then that cosine theta is just equal to g over L omega squared, or theta is equal to the angle whose cosine is g over L omega squared. And let's say that L is equal to 1.5 meters, and let's say that g is equal to 9.81 meters per second squared. So if we put those things into this equation right here, this is equal to the angle whose cosine is 9.81 divided by 1.5 times whatever omega is squared. But let's see, omega is related to the frequency. Frequency is equal to omega over 2 pi. So that means that omega is equal to 2 pi f. But what is this frequency? This is the number of revolutions per minute. So that's equal to F is equal to 30 cycles or revolutions per minute, and there's 60 seconds in a minute. So this is just equal to 0.5. And that means then that omega is equal to 2 pi times 0.5 or 1/2 or just pi. So this is just pi squared. And that means then that theta is approximately equal to, once you put this in the calculator, about 48.5 degrees. That's how you solve that.